Now, as we have prepared both receptor and ligand, we are ready for performing docking using AutoDock. We open both receptor and ligand PDBQT files. Both receptor and ligand are now ready for docking. We specify our receptor as macromolecule in the grid option. It's time we select the amino acids of the active site of the receptor. Once it is selected, it will be highlighted in yellow in the sequence. It seems the amino acids are in the A chain. You see that sequence highlighted in yellow. Probably that's our active site. It's time we generate the grid box. The spacing is generally 1 angstrom. But in this case, as 6Lu7 is a small macromolecule, we take the spacing as 0.5 angstrom. We adjust the x, y and z coordinates of the grid box in such a way that it covers the entire active site. The grid box specifies the site where the potential energy is allotted. The dimension of the grid box is generally 40 on all sides. Now we save the dimensions of the grid box in a text file. The output of the grid is saved in GPF format. Next we run a very important step, which is AutoGrid. We find out and select the AutoGrid application and specify out GPF file. Our AutoGrid is running. AutoGrid is completed and is now saved as few map files in the specified folder. Map describes our grid. Final step is to run the AutoDock. For this we set out receptor as rigid to simplify our calculation. We have previously set our ligand as flexible by assigning torsion to it. We use genetic algorithm as our searching parameter. We keep the number of runs short for tutorial purpose. We save the file in DPF format. Finally, we run the AutoDock by selecting the AutoDock application and specifying the DPF file. Hooray! It's running. The time taken to run entirely depends on your system speed. You will find a DLG file as output. It's still running.
One eternity later.
Here is our final output, where the poses and the binding energy are ranked with the least energy on top. It's the best post.